All right, we're going to do the S11B amplitude period principal axis and cosine and principal behavior handout. Okay, so first we start off with this problem, and they tell you that this iron asteroid is said to be valued at 8,973 quadrillion euros, and a quadrillion is 10 to the 15th power. So what we really have here is 8,973 times 10 to the 15th power. If I'm going to write this in this kind of form, where a is between 1 and 10, that means we're going to be putting a decimal. They want you to put a decimal right here. And the reason is because if I put a decimal right there, I've got 8.973, and 8.9 is in between 1 and 10. So, and then we're going to have times 10 to some power. Now let's think. Okay, so I've got this times 10 to the 15th. And if I want to figure out the power, right now there's currently a decimal point right there. And I'm going to have to move it over 1, 2, 3. So if I'm moving it over 3 spaces to the left, I'm going to have to increase this power 3 to the power of 18. Okay? Euros. Okay? There we go. All right, next. The radius of the asteroid is this, and we want to find the volume. So if you take out your formula packet, and so the formula packet, and you go to topic 3. Topic 3 has volume of a sphere, 4/3 pi r cubed. Okay, and we know that the radius is 113. So we just plug in 113 in for the radius, and then we get this is equal to so 4/3 pi times 113 cubed, and you get 6043992. Okay, and we can we're going to use this value exactly like this for part C, but if I wanted to write this in scientific notation, I can write this as 0.4 times 10 to the 6th power. Okay, so now we've got 6.074 times 10 to the 6th. So if we want to find percent error, I'm going to go to my formula packet, and we go to topic 1 on the formula packet. And for this formula, it was topic 3 on the packet. Okay. So, and when you go to topic 1, you're going to find percent error. Percent error is equal to the approximate value minus the expected value divided by the expected value. You might want to hit pause to copy this down. Okay, and so now I've done my calculations, and we figure out that, so our approximate value was the 6043992. I'm going to move the decimal there and forget the 10 to the power of 6 for all of these. And then I calculate it, and I get 0.00494, which simplifies to 0.494%. Okay, we'll be doing the definitions after we talk about our Desmos activity. Okay, so I'm just going to discuss the values because you did this during class. Okay, so what happens if Freddy the Frog's wheel radius has increased by a value of 2? So basically the height and the range is going to increase. So if his wheel has increased by a radius of 2, then we can put a value of 2 right here, because basically we're just multiplying 2 times all these numbers. So and I didn't fill out my table properly, but we can fill in the data here. So if I multiply 0 times 2, I get 0. If I multiply 0.707 times 2, I get 1.414. And all of these are 1.414, negative 1.414, negative 1.414. Okay, but anyways, what this does is it makes the maximum a value of 2, and it makes the minimum a value of negative 2. So it kind of stretched and changed the range. Okay. What happens if r is smaller? He gets on a smaller Ferris wheel. Then the maximum height is going to be 0.5, and the smallest height is going to be negative 0.5. Okay, and if I multiply 0.707 times 0.5, I get 0.3535. So basically I've taken all the values of y equals sine x, and we've multiplied everything times 1/2. Okay, and then that makes the height half as high as the yellow graph. You might want to hit pause and copy this down or check your work. Okay, next page. Freddy the Frog is on a faster wheel. Okay, so we're changing the period. So, how do you think his height will be affected when the ride goes faster? So basically, the pattern is going to happen twice between 0 and 360 if he's going faster. So this is going to change the length of the period. So let's talk about what that means. So y equals sine x you've graphed before already. It goes from 0 to 360. The maximum is 1. The minimum is negative 1. Here's my sine wave. Now if I've made it twice as fast, if you put the value right there, this is going to change the speed. Okay? So this changes the speed or the period. So when I get to 180, I've got 2 times 180, which is 360. So basically I've done the period, but I've done it twice as fast by putting the 2 here. So a period is when I start a wave and I get to the end before it starts to repeat itself. So it completes a period in 180 degrees. Here we completed the period in 360. So if I put a 4 here, it means I'm going to go 4 times as fast. So from here, you can see that it's making 4 periods. So a single period is done from 0 to 90. That's why the period is 90. And if I put an 8 here, that means it's going to go from here to here. It's going to make 8 of them. I didn't draw all of them, but you can hopefully see what's happening. Now what happens if I put a half here? That means it's going to go really, really slow. So instead of going faster, from 0 to 360 is only half of the graph. It's going to go from 0 to 720. Basically, what did I do? I multiplied 360 times 2. Okay. Now, predict the new period. So now we've got 1/4 x here. So if I go here, you can see that by the time I get to 360, I'm at the maximum. So in order to figure out what the period it's going to be, I'm going to multiply 360 times 4. Here, on the previous one, we multiplied 360 times 2. Hopefully you'll see the pattern in a few minutes. Okay, now Freddy's Ferris wheel is raised. We put a +2. So this creates a vertical translation, and we've moved the principal axis. We're going to talk about that in a second. That's one of our definitions. This pink line here is our principal axis, and we've moved up our principal axis to 2. So basically it looks the same. It's not stretched, it's not shrunk or anything like that. It's just moved up. It's translated up 2 units. Okay, and then the last one on this page here, the graph of the cosine looks like this. So if you played around with Desmos, you're going to see it looks like this, and basically what's happened here is if I put my hand over here, you can see that this looks just kind of like that, doesn't it? And what cosine, the graph of cosine, is the same as sine. It's just shifted over by 90 degrees. Okay. So now we're going to summarize everything that we just did. Okay, so the value right here affects the amplitude. That's how high the graph and above the principal axis and below the principal axis. So from the principal axis to the maximum, or the principal axis to the minimum, is the amplitude. The principal axis is the line that that your sine or cosine wave it kind of revolves. It kind of goes between. It's the center of the wave. Okay, it's the horizontal center line that the wave goes around. And now B affects the period. Now B is not the period, but it affects the period. So the period is when I've got a wave, and then it finishes the pattern, and then it starts over again from that point. So, and to find the period, it's 360 divided by B. So you should have noticed that when we did our previous page here. If B is 2, 360 divided by 2 gives me 180. If my B is 4, 360 divided by 4 gives me 90. If B is 8, 360 divided by 8 is 45. If B is 1/2, 360 divided by 1/2 is 720. Okay, so the rest you need to do for your homework, and you should check your answers here. You may want to hit pause to check your work. Okay, next page. You may want to hit pause to check your work. Okay, I'm going to move it up now. You may want to hit pause to check your work. And now I'm going to give you the definitions that we said we would give you later. And as I said before, you may want to hit pause to check to see that your definitions match what I have. All right. There we go.